Good morning.
Good morning, sir. So,
Okay, in the last lecture we have discussed down how to solve save method. Hope you all have cleared with that part.
Yes, sir.
Now, today we will take the one more topic, which is like similar to our previous section. Like just small changes is required to be done on that part. So let us understand that what exactly it is. So for today's lecture, you just write down the title as title is just write frequency or spectrum analysis of frequency or spectrum analysis of a signal using DFT. Frequency or spectrum analysis of a signal using DFT. Okay, so before going to start with, let us make some understanding here. So can anyone tell me DFT is used for finite duration sequence or infinite duration sequence? Can this DFT can be used to analyze a finite duration sequence or infinite duration sequence?
finite.
Finite. Very good. Right? Because we are taking the limit value of DFT is 0 to n minus 1. Matlab 8 sample, yeah 16 sample, yeah 32 sample. Likewise, it is a finite value we are calculating the DFT. Now, if you want to calculate a spectrum analysis, so either it may be a continuous time signal or it may be a discrete time signal. It requires all the signal to be present over the complete time. Right. So that means वो infinite signal का रहता है. So either if you are taking any infinite sequence of continuous time or it is a discrete time, its spectrum is having the value into the infinite value. Can we analyze that infinite value of a spectrum using DFT? Is it possible? Yes or no? If I have an infinite number of spectrum, like which is having the value from minus infinity to plus infinity, can we directly analyze that infinite number of spectrum using DFT? That's my question. Yes, anybody? Are you all there?
Yes, sir.
हाँ, कर सकते या नहीं कर सकते? कुछ तो एक बोलो. स्पेक्ट्रम का मीनिंग पता है सब लोगों को? Yes or no? Do you know the meaning of spectrum? What it
Yes.
is?
Yes,
What it
sir.
is? क्या रहता है? Spectrum means what? Yes? What do you mean by spectrum?
Band, band of colors or band of rim.
Band of? Yes, you are correct, madam. Please tell me once again.
Band of colors.
Band of colors. Okay. We are calling it as like काय म्हणतात त्याला? Specific word आहे ना त्याला? What is that? band of colors we can call, or it is simply a band of frequencies we can call. Or so that is what the spectrum, which may have a value from minus infinity to plus infinity, but directly that cannot be analyzed practically. So theoretically we can say that the spectrum is present from minus infinity to plus infinity. लेकिन हमें अगर theoretically practically अगर prove करना है, can we go directly for the infinite value? Infinite value का analysis हम कर सकते हैं क्या practically? Please keep on speaking. Can we go for that? कर सकते हैं या नहीं कर सकते? You need to tell me that. Hello?
Don't know, sir.
Very good answer. Right. Because practically, if we have any infinite value that cannot be implemented, बराबर, तो उसे हमें कुछ रिस्ट्रिक्ट करना पड़ेगा. We need to restrict for that, and we need to understand. जैसे कि like Fourier transform, which give you the time domain to frequency domain we are converting, बराबर. In Fourier transform also it is a transformation which is used to convert again time domain to frequency domain. So there again, the frequency domain sample you are getting as an infinite value. So that cannot be processed through a DSP. For that, we are converting that infinite value into the finite value by using the DFT operation. Okay. So that means to analyze this spectrum, infinite spectrum, we need to convert that into the finite spectrum. So for that operation, we are calling it as a truncating. Truncating means what? We are converting infinite structure into, or the infinite spectrum into the finite spectrum. That truncating operation we can perform by multiplying with one window function. Window function means what? It has some value. If it is a rectangular window, so it is present for particular value like 0 to n minus 1, and is if it is present like 1 for 0 to n minus 1, and it will be 0 for all other values. So that's what we are calling it as a window function. So that means if I multiply that infinite sequence multiplied with the window function, then we will get the value which is present for that particular window function only. So that operation we are calling it as simply the truncating operation. Okay. For example, simply I will tell you here. Suppose if you multiply periodic signal with non-periodic signal, result क्या आएगा आपका?
Non-periodic.
Non-periodic. यहाँ पे अभी एक स्पेक्ट्रम के साथ मुझे विंडो फंक्शन के साथ में मल्टीप्लाई कर रहा हूँ, तो आपका स्पेक्ट्रम कहाँ से कहाँ तक प्रेजेंट रहेगा? इट विल बी रिमेन प्रेजेंट फॉर द वैल्यू ऑफ दैट विंडो फंक्शन, एंड इट विल बी 0. Clear? So this way we are just analyzing. This is what the basic concept behind this. So now you just note down these points. So first, just write to compute the spectrum of either continuous or discrete time signal. To compute the spectrum of either continuous or discrete time signal. To compute the spectrum of either continuous or discrete time signal, the values of the signal for all time are required. The values of the signal for all time are required. For all time are required. The next line you write. But theoretically we can say this, but practically it is not possible. For that, what we need to do is, next point, the act of truncating. Just write. Next point, the act of truncating in infinite length duration signal. The act of truncating in infinite length duration signal to a finite length duration to a finite length duration is called windowing. Is called windowing. So here this window, as its name indicating, window का मतलब क्या है अभी? What do you mean by window meaning? Anybody? Hello? Meaning of window. सगळ्यांच्या घराला विंडो आहेत बरोबर. विंडो आहे का ना घरी? हाँ, तो मतलब क्या है? मतलब क्या है उसका? तो पूरा एक दीवार के ऊपर एक पर्टिकुलर जगह पे उसका विंडो का लोकेशन रहता है. दैट कंप्लीट दीवार जो रहता है वो हम इनफाइनाइट सिग्नल बोल रहे हैं. इफ आई एम जस्ट मल्टीप्लाइंग दैट कंप्लीट दीवार विद द विंडो, तो विंडो और दैट विंडो एक पर्टिकुलर एरिया पे प्रेजेंट रहता है वो, right? So that again, the complete this window methods and window types we are going to discuss in the next chapter. There again we may get more clear picture about this windowing techniques. So here we are just discussing one window as a rectangular window. हम सबके विंडो रेक्टेंगुलर है क्या? सर्कल है किसी के विंडो? है ना? सबके घर के विंडो रेक्टेंगल शेप में है, विच हैज लाइक लेंथ एंड विड्थ बराबर. तो उसको हम रेक्टेंगुलर विंडो बोल रहे हैं. ओके, व्हाट यू आर रिटर्न? What you are written?
The act of truncating an infinite length duration signal to a finite duration sequence is called windowing.
Windowing, full stop. Let x of n be an infinite duration signal. Just write. Let x of n be an infinite duration signal. X of n be an infinite duration signal, comma, omega of n, omega of n be a window function, omega of n be a window function, omega of n be a window function, and x cap of n and x cap of n be a windowed sequence, and x cap of n be a windowed sequence. Full stop. The simplest possible window function is
हॅलो सर,
yes madam.
तुमचा आवाज खूप हळू येतोय.
Okay, let me repeat once again. And x cap of n be a windowed sequence. येता का मॅडम आवाज आता?
नाही सर, हळूच येतोय.
सगळ्यांना सेम प्रॉब्लेम आला, फक्त तुम्हाला प्रॉब्लेम आहे? Is everyone is getting this problem?
No, sir. No, sir.
Maybe it's problem with you only, madam. You please check that. तर तसंच कंटिन्यू होत असलं तर यू जस्ट रिजॉइन हो जाओ, एक बार डिस्कनेक्ट करके रिजॉइन कर लो. And x cap of n be a windowed sequence, full stop. The simplest possible window function is, full stop, the simplest possible window function is the rectangular window function. The simplest possible window function is the rectangular window function full stop. Next line you write. Next line. The signal to be analyzed is passed through anti-aliasing filter is passed through anti-aliasing filter and sampled at the rate of, यहाँ पे anti-aliasing filter means which filter we are calling as anti-aliasing filter? Anybody? Which filter is called as anti-aliasing filter? Yes. DSP ब्लॉक डायग्राम में पहला ब्लॉक कौन सा है? The block diagram of
Low pass
DSP.
filter.
Low pass filter. Very good.
Low pass
So,
filter.
yes, madam. That anti-aliasing filter is a low pass filter here. Okay. Anti-aliasing filter and sampled at the rate of Fs greater than or equals to 2f max, and sampled at the rate of Fs greater than or equals to 2f max. Fs greater than or equals to 2f max. Full stop. Hence, highest frequency in the sampled signal is Fs by 2. Hence, highest frequency in the sampled signal is Fs by 2. Full stop. Next one you write. For spectrum analysis, some finite length of the sequences is taken. Finite length of the spectrum analysis. Sorry, for spectrum analysis, some finite length of the sequence is taken. Full stop. Let T be the sampling interval. Capital T is just right. Let capital T be the sampling interval and capital L be the number of input sequences are taken. Full stop. Then the time interval of the sequence will be T0 equals to capital T0 equals to capital L into T, capital T. The time interval of the sequence will be T0 equals to capital L into capital T. So this is already we have discussed like a sampling theorem. Sampling theorem statement we have seen. So that's with that implications I have just written that part. The next line. Let L, that is capital L, number of samples, capital L, number of samples of the sequence Hello, am I audible?
Yes, sir.
Okay, sorry for
Yes, sir.
क्या लिखे यहाँ पे?
L is
Can
equal
you
to number of samples
Let
of
L number
sequence.
samples of the sequence
let the L number of samples of the sequence x of n, let the L number of samples of the sequence x of n be obtained by multiplying multiplying x of n, obtained by x of n by rectangular window omega of n of length, by rectangular window omega of n of length L, So that means what we can write is, now here we are converting the infinite sequence into, क्या होता है अभी यहाँ पे x cap of n is our windowed sequence, as I told you already. Like x of n is here the infinite sequence which is multiplied with the window function. We are calling it as omega of n. Just write it out. Omega of n of length L. Then you write down this equation. X cap of n equals to x of n into omega of n. Are you getting this point? Hello.
Yes, sir.
Now
Yes,
here
sir.
omega of, okay, here omega of n is the rectangular window. Here omega of n is the rectangular window. Omega of n is the rectangular window which is given as, we just write this one, which is given as omega of n equals to 1 for the value 0 less than or equals to n less than or equals to L minus 1, and is 0 otherwise, So this is a definition of window we are writing here. क्या मतलब है इसका? Anybody? Suppose if we have L equals to 4. So what is its meaning? Yes. अगर आपका L का वैल्यू 4 है तो ओमेगा ऑफ n कहां से कहां तक प्रेजेंट रहेगा?
0 से
0 to 3.
0 to 3. अगर आप इनफाइनाइट सीक्वेंस उसके साथ अगर मल्टीप्लाई करेंगे तो आपका जो विंडोड सीक्वेंस आता है वो कहां से कहां तक प्रेजेंट रहेगा? अभी 0 to 3 तक प्रेजेंट रहेगा, तो बाकी वैल्यूज के लिए 0 हो जाएगा. गेटिंग माई पॉइंट? So this operation we
Yes,
are calling it as a truncating operation. Understood? Next line you write.
Yes, sir.
Next line you write. Let x of n be the cosine wave. Let x of n be the cosine wave consisting of, let x of n be the cosine wave consisting of single frequency. Let x of n be the cosine wave consisting of single frequency which is given as write this, x of n equals to cos omega 0 n. X of n equals to cos omega 0 n, right? As we all know that this cos function is a periodic function. बराबर?
yes, sir.
Yes or no? ठीक है. Now just write one line again after that. Then the finite length sequence x cap of n, the finite length sequence x cap of n becomes finite length sequence, x cap of n becomes, just write this, x cap of n equals to cos omega 0 n for omega 0 n for 0 less than or equals to n less than or equals to L minus 1. What is its meaning now? कोई बताएंगे मुझे? Yes? What is its meaning? Am I audible? Hello?
Yes, sir.
Yes, sir.
What is its meaning? I am writing here x cap of n equals to cos omega 0 n for 0 less than or equals to n less than or equals to L minus 1. So what does it mean here is simply, so this is our periodic sequence x of n and this is our window function, right? और ये window function कहाँ से कहाँ तक present है अभी 0 to L minus 1 तक present है. Getting my point? If this periodic signal is multiplied with this window function, then we are writing this x cap of n equals to cos omega 0 n is present only for this window limit value. So that's what I am writing here. बराबर? मतलब अभी cos का फंक्शन जो है हमारा वो सिर्फ वो विंडो फंक्शन की लिमिट तक ही प्रेजेंट रहेगा और बाकी वैल्यूज के लिए इट इज 0. That's what we are calling it as a windowed sequence. Okay. Understood?
Yes, sir.
Yes, sir.
Now let's write one more line. Here we have taken only L samples of cosine wave. Here we have taken only L samples of cosine wave. We have taken only L samples of cosine wave. Therefore, by definition of DFT, can anybody tell me what I can write here according to the definition of DFT? कोई बताएंगे मुझे अभी? डेफिनेशन क्या है DFT का आपका? हेलो, what is the definition of DFT?
Summation n equal to 0 to n minus 1 x of n omega n raised to kn.
Okay, so according to that we can write it now this way. तो वहां पे instead of x of n we are writing it as x cap of n. That's it. That's all is same again. So x cap of k equals to n equals to 0 to L minus 1. So this limit I am taking and the value is x cap of n e power minus j 2 pi by n kn for the value of k 0 to n minus 1. So this is the way how we are analyzing a spectrum or simply a frequency signal using a DFT. Just note the definition. Understood?
Yes, sir.
Just add one line there. This will help you for MCQ answering again. Next line. Have you noted that formula?
Yes, sir.
Yes, sir.
Next line, right? Actually, n greater than or equals to L, capital N greater than or equals to L, capital N greater than or equals to L, but spectrum is better. If we take large value of n, if we take a large value of n, that is capital N, compared to L, compared to L, capital L, the frequency spectrum compared to L, capital L, the frequency spectrum can be analyzed as x cap of k, with respect to k, full stop. Next line you write the total frequency range of 2 pi is divided into n points, that is capital N points, full stop. Hence the frequency resolution is 2 pi by n, that is 2 pi by capital N, and the individual frequency components are numbered by k. Individual frequency components are numbered by k in the range from 0 to 2 pi. So this all we have done at the start of the chapter second hour. Like we have done a frequency domain sampling and its reconstruction part. Okay. Have understood how we are analyzing spectrum using a DFT?
Yes, sir.
Okay. So this completes your third chapter again. So this is the last point of the third chapter. Now let's have some MCQ on this third chapter and we'll go for the discussion of assignment questions. Let's see, like we will have a discussion on MCQ and then I will go back to the assignment questions. Are you able to see my screen?
Yes, sir.
Okay, now it is your test now. Can anyone read the first question? What it is there? You please read that first question.
Overlap save algorithm uses overlap
for dash A bit output sequence, C bit input sequence, B bit both input and output sequence, and D bit adds the overlapped output. What is the answer? Yes, overlap save algorithm uses overlap for output sequence, input sequence, both input and output sequence, adds the overlap output. What is the answer correct here?
Input sequence.
Any other answer?
Yes, sir. Input sequence.
Still I want responses. Almost around 65 members are there. Only 2 response.
Input sequence.
Input sequence. Anybody else? In overlap save algorithm uses Anybody? So it is choice to you. Otherwise, I need to start taking roll numbers now. Yes? Anyone want to answer this? क्या कर रहे हैं वहां पे ओवरलैप सेव में? Ashwini Wagmode. Are you there, madam? Roll number 73. Ashwini Wagmode. Attendance लावून गेले वाटतंय. Yes, anybody? Why this C answer is correct? Input sequence. Can anyone justify it? फटाफट बाकी चलना है मुझे आगे और क्वेश्चंस. मैं बोलता हूँ आउटपुट सीक्वेंस करेक्ट आंसर है. So how do you justify your answer? Yes?
सर हम इनपुट सीक्वेंस एक्स ऑफ एन को ही ओवरलैप से यूज करते हैं ना.
हाँ वही तो पूछ रहा हूँ ना मैं, क्या कैसा करते हैं हम वहां पे? व्हाट वी आर डूइंग देयर? तो कैसा कर रहे हैं हम? ब्लॉक कैसा फॉर्म कर रहे हैं? In overlap save method, we are forming the blocks first by adding m-1 0 in the first sequence. Then in the second sequence, what we are doing? m-1, we are saving the last m-1 data points of the first sequence with second sequence, right? तो उसके लिए हम input sequence बोल रहे हैं. Is everyone clear about this point?
Yes, sir.
Yes sir.
Okay, very good. Let's go to the next question. With zero padding, DFT used as?
But वो इनपुट का हुआ ना, आउटपुट कैसे?
कौन सा?
First one, you just explained us about input sequence.
That's not like answer is input sequence only. To make your doubt clear, I just told that output sequence is the answer.
Okay.
The correct answer is input sequence only. Don't get confusion.
Okay, sir.
तो आप लोगों को बात करने लगाने के लिए मुझे गलत आंसर बताना पड़ा वहां पे. ठीक है? Is that clear now?
Yes, sir.
Okay. Now let's go to the second question. With zero padding, DFT used as? What is the answer? With zero padding, DFT used as circular filtering, linear filtering, FFT calculation, overlap add method. ये FFT वर्ड थोड़ा नया है आप लोगों को. हाँ.
Linear filtering.
Who is that? नाम बताएंगे मैडम?
Vaishnavi Gote.
वैष्णवी गोटे.
Vaishnavi.
Okay. Anybody else? Anyone? Any other answer? Why not circular filtering? Yes. यहाँ पे एक चीज आपको याद रखना है अभी. For filtering purpose, we are using only linear convolution. बराबर? तो circular filtering तो possible ही नहीं है. FFT calculation हम आज तक सुने ही नहीं है. सुने हैं क्या वो वर्ड?
No sir.
हाँ तो वो आता ही नहीं है. तो overlap add method तो possible ही नहीं है. Can you just this way the answer? Some logic should be there ना, कि like how to decide the correct answer. So with zero padding, DFT used as linear filtering. That's correct answer. Okay. Then next, third question. When recovered samples overlap due to aliasing, which following operation takes place? When recovered samples,
Addition. Addition.
Addition of overlapping samples.
when recovered samples overlap due to aliasing, which following operation takes place? Answer is
Addition of overlapping samples.
addition of overlapping samples. Is everyone will accept that this answer is correct?
Yes,
या और
sir.
दूसरों का किसी का दूसरा आंसर है? Yes, the answer is addition of overlapping of samples. Okay. Then question number 4. Aliasing occur in overlap save method, overlap add method, both A and B and D none. What is the answer here? The purpose of taking this MCQ is how much you understood the theory part. It is like kind of test at the end of the chapter. Aliasing occurs for overlap save method, overlap add method, both A and B and D none. What is the answer? कुछ तो बताओ यार. Yes. Which answer is correct? है क्या सब लोग उधर ही?
हाँ सर.
Guess what is the answer? इतना confusion है उसमें? What is the answer? In overlap save, let me give you the clue here, right? In overlap save method, what we are doing at the output? जो फाइनल आउटपुट आप लिख रहे हो, तो वहां पे हम क्या कर रहे हैं?
Discarding m-1 data points.
Discarding m-1 data points. Why? What is the reason for that? अगर वैसा ही रखेंगे तो क्या होगा वहां पे?
Aliasing.
Aliasing problem आएगा. Is that is the case with overlap add method? Overlap add method में वैसा हो रहा है क्या हम?
No, sir.
No, sir.
No sir.
नहीं है ना? तो क्या कर रहे हैं हम? जो y1 ऑफ n, y2 ऑफ n, y3 ऑफ n, y4 ऑफ n आने के बाद जब आउटपुट लिख रहे हैं तभी हम ओवरलैप ऐड करके लिख रहे हैं वहां पे. ठीक है. एक बार आउटपुट लिखने के बाद उसको हम कुछ मॉडिफाई नहीं कर रहे. आर यू गेटिंग माय पॉइंट?
Yes.
Yes, sir.
Wherein in overlap save method आउटपुट लिखने के बाद एक्स्ट्रा सैंपल्स को हम डिस्कार्ड कर रहे हैं. If we are not discarding those values, it is acting like a aliasing problem. What is the answer here now?
Overlap save method.
Overlap save
Overlap
method.
save method.
Overlap save method is the answer. Is everyone clear about this part?
Yes.
Yes, sir.
Now, question 5. Attendance लिखना बहुत गड़बड़ मत करो. I will give you the time on that part. But still we have a 10 minutes time. Concentrate on answering the questions. So which will be helpful for you again. Fifth question is, the size of input data block in overlap add method is?
L plus m minus 1.
The size of input data block in overlap add method is L plus m minus 1. Is everyone will go with this answer?
Yes, sir.
Yes, sir.
Okay, that's correct. Again, it is L plus M minus 1. Question number 6. Question number 6 is again multiplication in frequency domain is convolution in time domain. It is. Multiplication in frequency domain is convolution in time domain. It is. What is the answer? What is the answer? क्या आंसर हो सकता है यहाँ पे? और यार, it is a title of one of your property. Title of one of your property. Which property?
Convolution.
Huh?
Linear convolution converted to circular convolution.
No. Multiplication in frequency domain is convolution in time domain. It is a title of your one of the property. Or convolution in time domain is equivalent to multiplication in frequency domain. You can call anyway. Which property it is? Which property?
Sir, वो linear convolution की property है ना multiplication.
Linear convolution का property नहीं है मैडम वो. So multiplication in frequency domain is convolution in time domain, or we can read that convolution in time domain is equivalent to multiplication in frequency domain. Circular convolution we have studied. Multiplication of two DFTs is equivalent to circular convolution. Property study
Yes.
किया ना हमने, right? Multiplication of two DFTs is equivalent to circular convolution. That's what the meaning here. तो हमने वहां पे क्या किया थी? Convolution in time domain is equivalent to multiplication in frequency domain, or else you can write multiplication in frequency domain is convolution in time domain. One and same. The answer is circular convolution. This property already we have discussed. Yes or no?
Yes, sir.
Okay. Next question. Section convolution is performed if one of the sequence is very much larger than the other in order to overcome long delay in getting output, large space, memory space requirement, both A and B, and none. Section convolution is performed if one of the sequence is very much larger than the other in order to overcome long delay in getting output, large memory space requirement, both A and B, and none.
Both A and B.
Both A and B it is. It is same as a long duration sequence. जैसे कि हम दो type वहाँ पे we have studied like overlap save method and overlap add method, right? So because the longer length of the sequence directly processed cannot be directly processed through a DSP, so we need to make a section convolution in that, and then we need to process that. So उसके लिए it is the answer is both A and B. Okay. Next question number 8. The circular convolution of n-point sequence is evaluated in the range
0 to n minus 1.
It is 0 to n minus 1. The answer D is the correct answer. Okay. Next question number 9. The use of zero padding is answer A, better display of frequency spectrum, B, linear filtering, C, both A and B, and D, none.
Linear filter.
Yes?
Linear filtering.
Yes, the answer is linear filtering again. The next question number 10, we have it is, so when aliasing occurs, what is the answer? See, it may be asked in mathematical expression or it may be asked in this word form. So what is the answer here?
None.
None.
Yes, sir.
Why? Why none it is?
Because in aliasing problem, extra samples are there.
Okay. So can you think of with the C answer? Let me check the answer. Question क्या था अपना 11 or 10? 11 ना? No, 10. 10 is again like the answer D it is. Very good answer. Right? So when aliasing occurs, low frequency become high frequency become mid frequency, and high frequency above signal bandwidth become low frequency below signal bandwidth. So these are all the answers of the aliasing problem. Right? The condition, it's not mentioned over there. So it's going to be the answer is none. The next 11, in overlap save method, the convolution of various sections are performed by
Circular correlation.
Circular convolution.
Circular convolution.
very good. ठीक है. Next, while filtering long data sequence in one of method, the size of input data block is L. It is. When filtering long data sequence in one of the method, the size of input data block is L. It is. What is the answer? Which answer is correct here? क्या हुआ? Hello? Are you all there?
Yes, sir.
What is the answer? इनपुट डाटा ब्लॉक एल हम कहीं पे लेते हैं क्या इनपुट फॉर्म करते टाइम पे?
No, sir.
नहीं सर.
नहीं है ना, तो इट्स सिंपली नन. द आंसर इज नन हियर, क्योंकि वहां पे व्हाट वी आर टेकिंग इज एल प्लस एम माइनस 1 डाटा पॉइंट्स वी आर टेकिंग, मतलब टोटल जो लेंथ है उसका कंप्लीट आना चाहिए हमें. राइट? द आंसर इज नन फॉर दिस. सो प्लीज स्टार्ट मार्किंग योर अटेंडेंस. So while like another 1 or 2 questions I will take. So the circular convolution can be converted to linear convolution for sequence x of n of length L and the sequence h of n of length m by. What is the answer? Hello?
Making both sequence equal to L plus M minus 1.
Very good. Making both sequence equals to L plus m minus 1 is the correct answer. Now here For a periodic sequence, xp of n, L equals to minus infinity infinity, x of n minus Ln corresponding to x of k for k equals to 0, 1 up to n minus 1. Aliasing occurs when
N is less than L.
n is less than L. Very good. The next 15th question. Linear convolution of two real sequences with p and q points respectively can be converted to circular convolution by appending extra zeros to every sequence until its length is
P plus Q minus 1.
p plus q minus 1. Correct answer. 16th is a linear convolution result for zero appended real sequences after executing a circular convolution using FFT will go wrong if we use FFT of length n such that A is n less than p plus q minus 1, n equals to p plus q minus 1, n greater than p plus q minus 1 and none. तो यहाँ पे FFT को DFT बोल के कंसिडर करो. In next chapter we are going to understand what is FFT. What is the answer?
N is less than P plus Q minus 1.
How come it is, madam? Why it is less than?
Because at when N is less, that time only aliasing occurs and
Okay. So that's why like will go wrong if we use FFT of length n. That's correct, right?
yes.
The answer is n less than p plus q minus 1. Okay. So finally, last one, dash convolution is of no use if our objective is to determine the output of a linear filter to a given input sequence. What is the answer? Dash convolution is of no use if our objective is to determine the output of linear convolution, linear filter to a given input sequence. Answer? What is the answer? जब भी आपका filtering operation आता है, you have to blindly write the answer as linear. क्योंकि linear convolution is used for filtering operation, no other convolution. Understood? लेकिन यहाँ पे what is asked is dash convolution is of no use. Circular convolution you can write the answer, right? Circular convolution is of no use if our objective is to determine the output of a linear convolution. Have you got the idea now?
Yes, sir.
Yes, sir.
Okay. Thank you. We will stop it here now for the today. Start solving the assignment 3 also. Let's see, like, and still most of you are not submitted the 1 and 2 assignment. Please do that part as early as possible and submit it me on mail, not on WhatsApp. Please mark your attendance. We'll stop the session now.
हॅलो सर.
Yes, madam.
रेंज प्रॉब्लेम होता त्याच्यामुळे मी डिस्कनेक्ट झाले होते.
काय नाव तुमचं?
वैष्णवी गोटे.
ओके, ठीक आहे. मार्क केलाय का अटेंडन्स तुम्ही?
ओके सर. हा आता टाकलं चॅट बॉक्स मध्ये.
ठीक आहे. मी आता तुम्हाला जॉईन केलं आणि मी. ठीक आहे.
हा सर.
ठीक आहे, ठीक.
थँक्यू सर.
Still, if anybody is having the problem, let me know. संकेत भाई, निवेदिता, बाबा नगरे.